Whoops. Yeah. Hello, guys. I'd like to show you how to do an optimization. A simple one in this case that has a great effect. All right. So let me just stash my progress away here, and yeah, let's dive in. So we have this CTFE evaluator that is able to evaluate this function here, right? That just does this loop, and when we execute this with the vanilla DMD, whoops, let's give it the time command. There we go. When we execute this with a vanilla DMD, it's 680 milliseconds, which is quite a lot just to count to this number here. And do a smiley function calls. Now let's use my modified DMD with new CTFE, which I guess I forgot to recompile. This is already the optimized result. Okay, disregard that. Now let me recompile. And now I spoiled the fun a little. Now, this is still too good. Well, anyway, you can see this is faster, but it is not as fast as it could be. So let's see where our performance bottlenecks are. For this, we do one thing first, which is we go into the deflags and we enable debug info with a -g. We make this again. And then we call perf on this. This is this call. Instead of time, we set perf record. And then we say perf report. And it tells us that there's a small inefficiency in this IMM thing, which is used to create the immediate values in our call. And it's just a bunch of maths and layouts, and I think there's even a call there. Here, the constructor call, and it's just yucky and bad. It costs us 8% of performance, which we totally not need just to make an immediate value. All right. So now let's go into the source code and let's walk to this function. This is here, and it calls the constructor of IMM32, which just makes a uint, and then calls the constructor of BC value with that uint, and that constructor of BC value with that uint is here, and this is what it does. It sets the type, it sets the immediate, and that's that. Now we do manual inlining. We copy this source code of the function and we copy it in there into our convenience function. Convenience function, there it is. We just copy the source in here. Remove that one, and that one is no longer this, but redval, just result, result. This is not an 32, this is value. Okay? This can be result of type actually, to make it clearer. Alright? And we just have the BC value. BC value result. This is the initialization call we do, and then we return the result. Return result. Actually, we have to fix the indentation. Alright. Now this looks fine. We have to remove this white space and this one. And now our function should be more efficient. Let's rebuild. Of course we have to build with enable release. And now we look at the perf again when the compiling has finished, which now takes quite a bit longer. Probably because the optimizer, yeah, because we just compiled optimized. The DMD optimizer has a few things where there are n squared algorithms, which have an n squared algorithmic complexity, and you can see this. Yeah. We still have to wait a little. Well, I have to fix this at some point, but okay, we are there. And now let's do the same perf thing. The perf report. And we see that the BC thing that took 8% before is now gone. What does this mean now when we take the time? Well, let's see. It takes 143, and before it took 170, if I recall correctly. Let's go there. Here. We just saved 50 milliseconds by inlining a function manually. Let's give ourselves a hand. First, let's make sure that this was really what that helped by going in there and doing static if optimized here. Static if true, right? All false. Then we take this code path. Otherwise, we took what we had before, which was just return BC value of mm32 of value. Right. Now, let's make sure that this is what we compile. Yeah, because this is false, we will now compile our old version. You can just say make POSIX enable release 1. Like that. And it still takes a long time because DMD's optimizer and the inliner actually take a long time to do their work. Now, Well, yeah, should be finished any second now. So we can see if this version where we did the static if false and our optimized version is worse. Yeah, now let's take the time of this. And it's 160. And it keeps being like that, and before we had 140. So let's now again make this true, compile, and let's see if we really get 140 again, and if it wasn't just a lucky break, but we should get them. And that is yeah, like what, 3 or 2% of performance right there, just by one manual inlining, because the profiler gave us reason to believe that there was a problem there. And this is how you do optimization. It's really not that difficult if you have debug info enabled, which tells you which source code is the small one, the slow one, right? Now, yeah. Okay. Any minute now. Yeah. Right, let's do the time. Well, and it is 150 again. And before we had 160. So we have a win there. Not a huge win, but a win. Okay, this is all I want to show you, that it's actually really easy to do this.